Hello students, so welcome to the fourth lecture of modulus function. So in the last lecture we did the modulus equations. So in this lecture we will be doing some inequalities and some related results. Okay, suppose the question is we are starting with modulus function lecture 4. Suppose the question is solve mod x plus 1 is equal to mod 3x plus 2. Now question is how will solve this? Okay, can we write this as mod x plus 1 of mod 3x plus 2 equals to 1. Now what we have studied, mod a by b is mod a by mod b. So we can make use of this result. So it will be like this. So now we can easily remove the mod. So we can write x plus 1 over 3x plus 2, either it is equals to 1 or equals to minus 1. Now we can solve it easily. From this we can get x plus 1 is equal to 3x plus 2. So we have x equals to minus 1 by 2 from this relationship, and x plus 1 is equal to minus 3x minus 2. So from this relationship we have x is equals to minus 3 by 4. Either we can solve this as, instead of this we would have been solve it like this. From this step we can write my x plus 1 is plus minus 3x plus 2. Okay, or you can write 3x plus 2 is equals to plus minus x plus 1. This will also give the same solution. Or else you can do, what you can do from this step, you can do the squaring also. In all the circumstances you will get the same answer. If we do the squaring, so we will be having x plus 1 square is equal to 3x plus 2 square. By solving this quadratic equation you will get the solution. Okay, so I think we have given the sufficient number of ways of solving this. Now my next question is solve mod x is equals to 2x minus 1. Now what are the way to solve this? Okay, either I can make the cases like this. If x is greater than or equals to 0, then mod x is x. Then I can write this as minus x equals to minus 1. So I have x is equals to 1. Now the next case is when x is less than 0. So what I will obtain? Minus x is equals to 2x minus 1. So then in this case I will be having x equals to 1 by 3. This is the one of the way. Now the next question arises, if somebody asks, can we square it? Can we square it? Yes, we can square it, but we'll get some extra values. So now let us squaring both sides. Squaring both sides. Now if I do the squaring part, so I will be having x square is equals to 4x square minus 4x plus 1. Now see, what I will obtain, 3x square minus 4x plus 1 equals to 0. Now which is quadratic in, you can say that in this now that is what we say, that quadratic in x. Now one thing I just want to justify here, when x is less than 0, see, can it be a solution? Answer is no. Why? Because when x is less than 0 and x equals to, there is no common value. because here is 0 and here is 1 by 3. So this cannot be the solution. Okay. So on the right moment, I just found this. Okay, now let us simplify this. Now how will simplify this? Now look at this. Uh, Let us factorize this. We can write this as 3x square minus 3x minus x plus 1 equals to 0. So we can take common. So we have 3x minus 1 and x minus 1 equals to 0. So we have x equals to 1 by 3 and x equals to 1. Now x equals to 1 by 3 is not the solution. Even if you can check, it won't satisfy the main, this modulus equation. So I advise student be careful when solving the modulus equation, and please don't ignore the constant as I did in this particular case. Okay, now see what I will do here. If I substitute, my LHS is 1 by 3, my RHS will be, what is that, 2 by 3 minus 1. So what is that? That is nothing but minus 1 by 3. So the only solution is x equals to 1. So therefore, when you are solving modulus equation, so I would request that you have to be extra cautious so that you can get the solution. Now, my next part of this lecture is modulus inequalities. So let us focus what are the modulus inequalities. Modulus inequalities. Suppose if I would ask you that my mod x is less than or equals to 2. So what are the values of x? Now when I am writing mod x less than equals to 2, it should be understood that the minimum value of this mod is greater than or equal to 0. Okay. Now I want to shade the appropriate region. Now draw the number line. So this is minus infinity, this is plus infinity. Now first of all, what I would request, mark the point for which modulus is 2. So this is 2 and minus 2. Now I have to shade the appropriate region. My mod x is less than or equal to 2. So it means I'm interested in those points where I can, if I measure the distance from the origin is either it is equal to 2 or less than equal to 2. So I can say that this region, including both the endpoints. So I can say that in this particular case, my x will lie between minus 2 to 2. Now suppose, so can we say that from this, if I have mod x is less than or equals to a, and I'm writing a is positive, so can we say that my x is lying between minus a to a? Or else you can say that x belongs to the closed interval minus a to a. Now similarly, if I say that my mod x is strictly less than 2, so we will say that my x belongs to the open interval minus 2 to 2. The reason is again simple. This is minus 2, this is 2. Now distance from the origin should be less than 2. So we have this region. So this region is x greater than minus 2 and less than 2. Now my question is, are these inequalities same? If I am writing mod x less than or equals to 3 or 0 less than or equals to 3, can we say that these two inequalities are same? My answer is no. Why? In this particular case, my x will be between, that is minus 3 to 3, and here 0 is included, here 0 is included, and the meaning of this is x belongs to minus 3 to 3 except 0. So both are different inequalities. Now suppose I want to generalize this. If I'm writing mod x less than or equals to a, it means a is positive. So we can do the squaring. So by squaring we will have this. We can write this as x square minus a square less than equals to 0. So by sign scheme method, if I apply sign scheme, uh, this is minus a and this is a. So definitely this will be the reason. So my x will belongs to minus a to a. Now suppose if somebody ask you that solve this mod x less than or equals to 0. So but obvious it has only one solution because modulus cannot be negative. So the obvious solution is modulus of x equals to 0, and namely x equals to 0 is the only solution. Now my question is find the domain of this expression under root 7 minus mod 3x minus 5. Now what do you mean by domain? This square root has to be a non-negative quantity. So how will proceed? We should say that 7 minus mod 3x minus 5 must be greater than or equals to 0, greater than mod 3x minus 5. Or you can say that mod 3x minus 5 is less than or equals to 7. Now I already given the result that when mod x is less than or equals to a, my x is lying between minus a to a. So we can write this as 3x minus 5 must be lying between minus 7 and 7. Now adding 5, minus 7 plus 5. So on LHS we have minus 2 equals to 12. Now dividing by 3. So minus 2 by 3 x. So the domain of this expression is close interval minus 2 by 3 to 4. So these are the values under which this function can be defined. Now we have another question on the modulus inequality. The question is, say, solve modulus of x square minus 7, say less than equals to 9. How you will solve this? We know that we can write this as x square minus 7 must lying between minus 9 and 9. Now what I will do? Add 7. If I add 7, then minus 9 plus 7 less than equals to x square less than equal to 9 plus 7. So what I will obtain? Minus 2. Now but obvious since it is x square, so x square is a non-negative quantity, so its minimum value I should take, it should be x square cannot be negative, less than equals to 16. Okay. Now now we have to solve this part, and this is nothing but you can say that your x belongs to minus 4 to 4. Minus 4 to 4. If somebody says, sir, that why you ignore that? Suppose I can solve it in another way. I will consider the two part of the inequality here. So one part is this and one part is this. Suppose if I do consider this, I will say that it is true for all x belongs to the real number. And if I'm writing this x square less than equals to 16, so I will say that x belongs to, that is x lying between minus 4 and 4. So in this case, I need to find the common reason of this. Now what is the common between the entire real line and this solution? So the common reason will be x lying between minus 4 to 4. So either of the way you can find the solution. Now we have another question. Say solve mod x square plus x minus 6 strictly less than 6. So by definition, or also by the concept that we have done, that mod x less than a, we can write x is more than minus a and less than a. So we can write this as x square plus x minus 6 greater than minus 6 and less than 6. Now this become x square plus x. I'm adding 6 to the entire inequality. Now this inequality has two parts. What are those parts? The first part is this one, and the second part is this one. And then later on we'll take the intersection. That is x square plus x is greater than 0. So x into x plus 1 greater than 0. Now using sign scheme method or Wavicom method, we have 0 and minus 1. Now on right side of the 0 it is plus, minus, plus. So clearly the reason, this reason will be neglected. Now another one is x square plus x minus 12, that is less than 0. Now if we split the middle term, so we'll have x minus 3, x plus 4 less than 0. Now let us sketch the region. Now we have minus 4 and 3. So on the right side of 3, what will be the sign? Definitely it will be positive, and here it will be negative and positive. Now what I have to do, we have to take the intersection of the both. Now if I take the intersection, now what will be the intersection? Now see, the intersection will be, since we have the reason here is minus 1 and here it will be minus 4, okay, and then we have 0 and then we have 3. Now on the right side of 3 it is plus, okay, and we need minus 4 to 3 and this region. So the common region will become, that is minus 4 to minus 1 union 0 to 3. That will be the solution. If you want to find the common region, so I'm just shading. Suppose first I want to shade this one, that is minus 1 to infinity. This is the first region, and the second one is 0 to infinity. Okay, now we have the region minus 4 to 3. Now minus 4 to 3 will be this region. Now look at this. Now where the color is changing? The color is changing here, minus 4 to minus 1. This is the common region, and 0 to 3. So this is the intersection, guys. Okay. Now we have another question. The question is, solve mod of mod x minus 1 minus 2 less than 5. Now let us work out on this. So again I'm using the inequality mod x less than a, means x is more than minus a and less than a. So it means mod x minus 1 minus 2 lying between 5 and minus 5. Now adding 2. If I add 2, then it will be minus 3 mod x minus 1, and what about this is 7. Now we have the two parts of this inequality, and certainly what should I say, that mod x minus 1, what it will be? It will be always greater than or equal to 0. Okay, we have these two inequality, but if I want to write this, I should write that my mod x minus 1 is always greater than or equal to 0 and less than 7. So what I will do, I will consider this part, mod x minus 1 less than 7. So x minus 1 lying between minus 7 and 7. So your x lies between minus 6 and 8. So our solution is x belongs to the open interval minus 6 to 8. So this is the solution, guys. So it is very easy to solve this. Now suppose instead of that, suppose if I would ask you what is modulus of x greater than or equals to 3. Now in this case, what I need, I'm just measuring the distance from the origin, and the distance has to be 3 or more than 3. Suppose this is 0, this is 3, this is minus 3. Now what I require, I want to have the distance, it has to be at least 3. So 3 or more than 3. So this distance and these points we are covering here. It means I can say that this will imply either x is more than 3 or x is less than minus 3. You can like or say greater than or equal to 3, and so you can say that x belongs to minus infinity to minus 3 union 3 to infinity. So very easy to mark this type of regions. So now let us consider mod x greater than or equals to a. Certainly I am considering a is positive. So I can say that my x will belongs to minus infinity to minus a union a to infinity. In fact, we can do this by squaring also. If I want to achieve this, if we do the squaring, this is mod x square greater than or equals to a square, and we already discussed mod x square is same as x square is same as mod of this. So we have x square minus a square greater than or equals to 0, x minus a, x plus a greater than or equal to 0. So by sign scheme, we can easily say that my x belongs to, that is minus infinity to minus a union a to infinity. That is x is greater than or equals to a or x is less than or equals to minus a. So these are the solutions. In fact, if I want to generalize this in general, if I say that mod of some function, say fx, is greater than or equals to a, so then certainly the fx will belongs to this interval minus infinity to minus a union a to infinity. Now let us solve one problem so that you can understand the concept. If I say that solve this mod 2x greater than or equals to 3. Now what is the meaning of this? That is either 2x is greater than or equal to 3 or 2x is less than equal to minus 3. That is x is either greater than 3 by 2 or x is less than minus 3 by 2. Now if I want to write in terms of intervals, then it will be x from minus infinity to minus 3 by 2 union 3 by 2 to infinity. So it is not so difficult to simplify such type of inequalities. Now let us consider one more problem. We have, suppose we have to solve this mod 2x minus 3 greater than 5. Now what is the meaning of this? Now let us apply the meaning. If I am writing mod x greater than a, then certainly it will say that either x is more than a or x is less than minus a. So here x is replaced by 2x minus 3. So 2x minus 3 is either greater than 5 or 2x minus 3 is less than minus 5. So we can say that 2x is greater than 8, x is greater than 4, or you can say that 2x is less than minus 2 or x is less than minus 1. Now in terms of interval, how we can write this? My x belongs to minus infinity to minus 1 union open interval to infinity. Guys, certainly you must be enjoying these problems because it is not so difficult. Once the concept is mastered, then you can play with these results. So now let us solve one more problem on the modulus inequalities. Suppose the question is solve mod of mod x minus 1 minus 3 greater than or equals to 2. Now again we know that mod x is greater than or equals to a, this is true when x is greater than or equals to a, or x is less than or equals to minus a. So we have the two parts in the inequality, mod x minus 1 minus 3 greater than or equals to a, or you can say that mod x minus 1 minus 3 less than or equals to minus 2. Now mod x minus, so here it is 2. I have written a. Mod x minus 1 must be greater than or equals to 5. Now what is the meaning of this again? What can we say about this? Its meaning is x minus 5 greater than x minus 1 greater than or equal to 5, or x minus 1 less than or equals to minus 5. So x greater than or equals to 6, or x less than or equals to minus 4. Now let us simplify this part as well, or mod x minus 1, what should I write here? Less than equals to 1. So its meaning is x minus 1 must lie between minus 1 and 1. So if I add 1, so then 0. Okay. Now my solution will be union of all these intervals. Union of, so my solution will be x belongs to minus infinity to minus 4. I am writing this. Union close interval 0 to 2. Union, I have written this, and now writing this 6 to infinity. Now look at this. We have solved this easily. Now we have one more problem on the modulus. The question is solve 1 over mod x minus 3 less than 1 by 2. Now the question arises, can we multiply both sides by mod x minus 3? Of course not, because we don't know what is the value of x. Can we cancel it or not? So the best way is bring this term on the LHS. This is less than 0. Now let us take the LCM. So what I will obtain, I will be having 2 minus mod x plus 3 upon twice of mod x minus 3 less than 0. So what we can write this is 5 minus mod x over 2 times of mod x minus 3 less than 0. Can we write, I just want to make the coefficient of mod x positive, so multiply both sides by minus mod 2 times of mod, that must be greater than 0. Now 2 is positive, so I should say that I should solve this. This is mod x minus 5. I written entire mod. So we can write this as mod x minus 5 upon mod x minus 3 greater than 0. Now if I take mod x is equals to t, then my inequality reduces to t minus 5 upon t minus 3 greater than 0. Now let us use the sign scheme method. Now my numerator has the 0, 5 and 3. So this is 5, this is 3. So on the right side of 5, it is plus, it is minus, it is plus. So what we need? So we can say that either t is greater than or equals to 5, or t is strictly less than 3, because t cannot be equal to this. And in fact, it is a strict inequality. So I should write t greater than. Now what is t? Mod x, or mod x less than 3. Now what is the meaning of mod x greater than? Its meaning is I can write directly my x belongs to minus infinity to minus 5 union. Now what is the meaning of this? I'm writing simultaneously minus 3 to 3 union 5 to infinity. So this is the solution, guys. Now look at this. So we have solved it by using the similar concept that we did earlier. Now let us consider this equation, that is solve mod of 1 plus 3 over x greater than 2. Now how will solve this? Now, what is the meaning of this? This is modulus. Certainly its meaning is 1 plus 3 by x, either it is greater than 2 or 1 plus 3 over x is less than minus 2. Now let us solve one by one. Uh, can we write this as 3 over x? If I bring this 2 on this side, so minus 1 greater than 0. So we can say that 3 minus x over x greater than 0. So you can either say that x minus 3 over x is less than 0. Now let us use the sign scheme. So this is 0, this is 3. Now on the right side of 3 it is plus, it is minus, it is plus. So we can say that from here my x lying between 0 and 3. Now let us solve this part of the inequality. We will have 3 plus 3 by x is less than 0. We can write this as further thrice of 1 plus x over x less than 0. Now let us use the sign scheme. This is 0, this is minus 1. Okay. On the right side of the 0, certainly it will be positive, negative, positive. So from here, we can say that my x is greater than minus 1 and less than 0. Now my solution will be union of these two solutions. So my solution is x belongs to minus 1 to 0 union 0 to 3. Okay. So I hope guys you understood this. Now let us solve one interesting inequality. Suppose my inequality is solve 2 is less than equal to mod x is less than equals to 5. Now how will solve this? Now it has two parts. It has two parts. Now let us simplify it. If I want to simplify this, mod x less than equals to 5 and mod x greater than equals to 2. Let us mark the region and then we'll find the common region. We have here say minus 5 and this is 5. The reason of my this inequality is this one, that is minus 5 to 5. Now mod x greater than equal to 2 means either x is greater than equal to 2 or x is less than equals to minus 2. Now here is minus 2 and here is 2. Now if I want to plot their region, then I should say that x greater than equal to 2. Now see where is the color changing. So what are the common region? This is the common region, guys. So what can we conclude from here? So we can say that my x is greater than or equals to minus 5 less than equals to minus 2, okay, or x greater than or equals to 2 less than equals to 5. So this is the solution. Now straight away can we make some result from here? If I say that my mod x is greater than or equals to a and less than equals to b, so I can straight away say that my x is greater than equals to minus b less than equals to minus a, or x is greater than equals to a less than equals to b, or in terms of interval I will say that x belongs to close interval minus b to a union a to b. So this type of results we can use directly in the questions. Suppose we have the question, solve 2 is less than mod x minus 2 less than equals to 3. Now how will solve this? Certainly I will apply this concept, mod x less than greater than equals to a less than equals to b. If I apply this, so then certainly I will say that my x minus 2 will be greater than equals to minus 3 but less than minus 2, or I will say that x minus 2 greater than 2 and less than equals to 3. Now, what next? We can say that adding 2 both side 0 and greater than 4 5. Here it will be equality. So your solution is x belongs to minus 1 to 0 open interval union open interval 4 to 5 close interval. So I hope guys you have understood all the concept that we have discussed in this video. So we have solved so many problems in this video. So I would request each and every student, so please kindly master these type of problems, because this will certainly help you while solving the concept of functions. Okay, then bye. So wait for my next video.